Hi, I'm back at it again and I'm live. Okay, so I'll be my student right here and we're gonna do a short video about logarithms and how to actually understand it. So, logarithms is something that is very easy. So, logarithm is something you usually learn after you learn what is graphing and what is it about. So, logarithms, we have a few things. Usually, when you first learn logarithms, your teacher will tell you there'll be a log, and then sometimes you'll have a log base 10. So I can't really like base, so I'll write the bracket 10 here. So you just assume it's log base 10. And then you have an x value after that. Sometimes you have a short form, it's like log. So this stands for log base 10 lah. And also you have ln. Ln is basically means it's log, but then you base e. So that's what it means in logarithms. Now, logarithms is something that we learn usually to study like rate of reactions in chemistry. That's one of the usage in chemistry. So usually in chemistry, right, we have like a line and then we have a curve. So the curve looks something like this. So you will have a curve like that and then you drag it out like that. So we have this kind of curve in chemistry. So it's like a very steep reaction rate and then suddenly it just decreases as it progresses. So this is what we call like something we do with logarithms. So we also have natural logs. So natural logs, instead of they look like this, they're gonna look something like this. So you have a curve is like that, and then it looks something like that, something like this. So usually something like this, we're gonna use it and we'll express it through logarithms. So logarithms is something that usually we don't. It's like a straight line, but it's also like a curve. Okay, so usually in this case, I would usually recommend you to open something using called Desmos. So in here, I've already shown you like what are the examples here. So today we're going to be focusing on the logarithms part here. So I'm gonna remove the blue color line here, and then we're gonna test out like what do logarithms actually mean and how do they actually look like. So most of us we don't know what do log base 10 mean. So I'm just gonna set here. So we have the log bx here, if you can see, log bx. So my b value will be my base value. So now I'm gonna do log base 10. So it's gonna be a log base 10 graph. So when you look at here, is log base 10, and the x will be depending on the values here. So let's say with the number, the x is 1. You can see at log base 10 1, log base 10 1 is 0. Then at log base 10 2, the y is 0.30103, which is here, around here. So now you can see the log base 10, the values will change. Let's say it's 4, 6, 7, 8, 9, 10. When it reaches 10, it hits 1. So log base 10 10, it hits 1. So that means this is how the graph will look like if it's a log base 10. So one of the functions you use logarithms is in chemistry to study rate of reaction. But logarithms, you can usually use it for many more stuff aside from that. But today, you're going to focus on how the graph actually going to look like. So let's say, for example, what happens if I change the log base to log base 9. Okay. If you look at this particular side of the graph, the table right here, you can see that if I change from log base 10 to log base 9, it means that the curve now shifts when it's at x equals to 9, log base 9 equals to 1. Now, and I change again to 8. You can also see that at log base 8 it equals to 1. So log base and to its same number, let's say log base 7 7, it will become 1. So let's say 7 7, it become 1. And same, log base 6 6, it becomes to 1. Log base 5 5, it becomes to 1. So logarithms, as you can see, the graph is like getting steeper and steeper and steeper. So if we were actually to go we can go until 1.5, 1.2, 1.1, and then at 1 it disappears. At 1 it disappears because log base 1 1 is literally just a straight line. So that's why it disappears. So now there's also negative logs. That negative log doesn't exist, but negative 0 point something exists. So you can like you can see, but it's inverse. Now it inverse. So just now we saw that it's 0.1. You notice that 0.1 looks similar to 10. So this is the something about logarithms that you should know if it's the base is lesser than 1. So log base 0.1 is like the inverse of log base 10. So that's the key thing to logarithms. So logarithms is to study the graph. So one way for you to understand really better compared to like, you know, you listen to your lecturer and then it's like teach you the formulas, like how to switch from logarithms to the exponential form thing. You should actually understand what the logarithms mean. Logarithms basically is like a way to express an exponent in an easier, in a logarithm form, because you can actually switch from an exponent to a logarithm form. And how do you switch it? Well, I'm going to show you how here. So usually you have a logarithm. You have, let's just say, log, and then you base 10. Okay, let's just say XR. Log base X. So this X, I make it smaller a bit. I move it to 18. And then I go back to 22. Log base XA. Oh shit. Okay, let me make this even smaller. 20, I change it to 10. Okay, log base XA. I want to change it into log base XA equals to B. Okay, and I want to change this back into indices form. So it's very easy. So the formula is here is X to the power of B equals to A. So how you're going to write it is just basically write X to the power of B equals to A. That will be how you change your logarithms into your indices form or exponent form. So here, if I draw the pencil, it's basically X to the power of B equals to A. So same thing if you want to convert like from exponent back to logarithms, it's the same reverse method. So it's basically log X A equals to B. So if you see, it's like a recycle kind of form thing. So you can use this as like a tips to how do you understand logarithms a bit better. So that's about it, guys, for today, and I hope you guys learned something. Okay, and see you guys in the next video. Bye.